Hi Year 12s. This is the second video on power functions. Today, we will be looking at what happens when our power function is to the power of a fraction, rather than a whole number. Firstly, we will look at a power function with a positive fraction. The power function is represented below as a variable x to the power of 1 over n, where n can be any integer. This is the equivalent of any square root of x to the power of n. When n is even, our function has no values along the negative x-axis, since we cannot have the squared root of a negative number. When n is odd, our function has the domain of all real numbers, as we can have the cubed root of a negative number, as well as a positive number. These basic functions are not too hard to draw, provided we remember the shape and a few general rules. The first step is to identify whether they are the square root to an even or an odd number, to determine the domain. We can see that the square root of x has an even value. Therefore, it will only be in the first quadrant of the graph. We can see that the cubed root of x has an odd value. Therefore, it will be in the first and the third quadrants. The second step is to know the path of our untransformed functions. The root of 0 will always be 0, and the root of 1 will always be 1. Therefore, we know both graphs will go through the origin and the point of x equals 1 and y equals 1. For when n is an odd number, the graph will also go through x equals -1 and y equals -1. However, when n is even, the functions are not defined over that range. Remember, it is also a good idea when drawing these graphs by hand to label another random point, so that we know we have drawn the graph correctly and the examiner can see that it is the correct graph. Now, we'll take a look at the most complex case, x to the power of a negative fraction. This can also be written in the form of 1 over x to the power of 1 over n, or 1 over the square root of x to the n. The first step is to know our domain. So, we need to identify if n is even or odd. If n is even, the domain will be 0, not included, to infinity. And if it is odd, all real values bar 0. The main difference here between the positive power fractions is that the domain does not include 0, since we can never have a number divided by 0. As we saw before, when n is even, the function will be only in the first quadrant, and when n is odd, it will be in the first and third quadrant. Our second step is to realise that all these negative fraction power functions will travel through the coordinates x equals 1 when y equals 1. The odd functions will also travel through x equals -1 when y equals 1. The third step is to identify the asymptotes. Obviously, we can't divide by 0, so there is a vertical asymptote when x equals 0. As x approaches infinity, we can see that the fraction will grow increasingly smaller. However, it will never actually equal 0. Therefore, there is a horizontal asymptote at y equals 0. Fourth step, we should know the basic shape of x to the power of a negative fraction, which we will show you in an example. Then, draw that shape, labelling a random point to check our shape and show to the marker what we have drawn is correct. For an example, let's take y equals 1 over the cubed root of x. If we follow our steps, it's easy to draw. First, we can see it is a negative power function with an n value of 3. Therefore, the domain will be all values except 0. Secondly, because we know it's an odd function, we know it will travel through the points of x equals -1 and y equals -1, and through the point of x equals 1 and y equals 1. Thirdly, it will have asymptotes at x equals 0 and y equals 0. These functions will become more complicated as we add in transformations, and we have to alter the points the function travels through. But we will deal with that later. Until then, happy studying!